Hey guys, this is going to be a video covering the progress check B, which should be done as homework along with 1.5 through 1.8. Okay, so for this question right here, we have a piecewise function. And in this piecewise function, we're evaluating the limit as x approaches 1 from the left of f of x. So just as you can see here, this function has two pieces. On the left side, we have 2x plus 2 up until x equals 1. On the right side, we have x squared plus 4 for every value that is greater than 1 on the x-axis. So since I'm only evaluating the value at x equals, as x approaches 1 from the left, I essentially don't need from the right, and you can also tell from this piecewise function that the function is not defined at 1, but that doesn't matter because we're not trying to figure out what the function is at 1. We're only trying to figure out what it's getting close to from the left side. And all I really need to do is substitute the value of 1 on the left part of the function, and I'll get my answer. So I'll let you guys go from there. Question 14. So the graphs of functions f and g are shown above. The value of the limit as x approaches 4 of f of x plus 6 over g of x. Okay, if you're wondering what to do here, you can use your properties of limits, which allow you to essentially break this down into pretty much 3 distinct limits, so long as the limit as x approaches 4 of that denominator does not equal 0. So you can probably just do a really quick check of that. So the limit as x approaches 4 of g of x, it looks like it's going to be 5. So it's not 0, so you can apply all property limits here. So just apply the limit as x approaches 4 of f of x, of 6, of g of x, add, divide, and go from there. Question 15. So let's take a look here. I think it's the same thing as question 14. It's just trying to get you to use your limit properties. So long as the denominator does not come out to be 0, you should be good there. And just don't forget that if you have any constant value raised to the power of 0, it's going to be equal to 1. Okay, so you're just using limit properties here. If f is the function defined by f of x, and we're given that there, then the limit as x approaches 4 of f of x is equivalent to which of the following. So also note here, you're not actually trying to find the answer to this right here, but what you are trying to do is to simplify the function to see what it's equivalent to, which of these statements it's equivalent, and you're going to want to use the conjugate method. So you have x minus 4 on the numerator. You have a square root of x minus 2 on the denominator. So multiply the top and bottom by the conjugate of the denominator. And the conjugate of the denominator is square root of x plus 2. So if you multiply that to the top and bottom, don't forget that on the bottom you're going to want to distribute, and then just simplify from there. And then see which of these would be equivalent to that. Question 17. I'm looking at this one right here. You're trying to apply the limit as x approaches 0 of that function right there. You can't use substitution because if you plug in 0 into the denominator, you get 0. So can you factor and get rid of that? And you should be able to. So I can already see I can factor out like a 3x from there, and from the numerator I can factor out an x, which would get rid of your problem, just like that. And then once you do that, substitution should be an option, and you should be able to evaluate it from there. Okay, here we have f of x is equal to cosine of x minus 1 over sine squared of x. Then the limit as x approaches 0 of f of x is equivalent to which of the following? You're trying to simplify these ones, so this one's probably going to be a little tricky right here. So I would recommend that you go use my solutions key for this one if you get really stuck. But essentially what you can do to start with is use some trig identities. So for example, sine squared of x is going to be equal to 1 minus cosine squared of x. Maybe I can get you guys started here. So we have the function given as cosine of x minus 1 over sine squared of x. And so there's the trig identity that sine squared of x plus cosine squared of x is equal to 1. Therefore, sine squared of x is equal to 1 minus cosine squared of x. So I can write this as cosine of x minus 1 over 1 minus cosine squared of x. Now don't get too excited. That doesn't fix anything right here because that's not squared. This is squared. But I will point this out right here. Difference of squares. And I think that's all I'm going to say. Try and see if you can simplify it just a little bit more, given that hint right there. See if you can simplify and get something that looks like one of these expressions right here. Alright, on to the next one. So we have, if f is the function defined by f of x equals x minus 1 over 1 minus 1 over x, then the limit as x approaches 1 of f of x is equivalent to which of the following? So if I try to plug in 1, I'm going to run into a problem, especially on that denominator right there, because I'll get 1 minus 1 over 1, which would then just be 0. And then that can't happen when you're evaluating a limit, so you're going to want to try and simplify this. So I would just recommend that on the denominator, try to combine that, because that is 1 minus 1 over x. So if you can combine that into one expression, so get a common denominator, just x over x. I'm giving way too many hints here. Get a common denominator, simplify that denominator so that you don't have two different expressions. From there, you can use a keep, change, flip method and simplify, and then you can simplify your entire expression, see which one you come up with, all right? So that's what you're trying to do. You're just trying to simplify the expression using algebraic manipulation. So this next one, let f and g be functions such that the limit as x approaches 4 of g of x is 7, and the limit as x approaches 4 of f of x divided by g of x is equal to pi. What is the limit as x approaches 4 of f of x? Okay, so for this one, you're trying to use your property limits. So this one's going to be like using algebra as well, in a sense. So, because you know that you can split that limit up. So the limit as x approaches 4 of f of x divided by the limit as x approaches 4 of g of x, and that's going to be equal to pi. From there, well, again, since you split that up, you're given that the limit as x approaches 4 of g of x is 7, so you can replace that with 7. And then you'd have the limit as x approaches 4 of f of x divided by 7 is equal to pi. Just use some algebra, and you can find the limit as x approaches 4 of g of x. Alright, so for this one right here, we have f of x is equal to, we got this piecewise function, we have absolute value of x divided by x for x is not equal to 0, and then we have 0 for x is equal to 0. So I'm going to give you the same advice that I did in the homework. So if I have f of x is equal to, I'm trying to think what it said, it was x divided by the absolute value of x, other way around. And x cannot equal 0 there, and then it's going to be equal to 0 when x is equal to 0. So it seems like here there's two parts, but there's actually three parts. So here's the first part at 0, but then to the left and to the right, it's going to be this function. And this function right here, again, the absolute value of x is a piecewise function in and of itself. It's equal to negative x when x is less than 0. It's equal to regular x when x is greater than 0. So So I can even expand this function, piecewise function, into more distinct 3 parts. So let's say for the left side of 0, the absolute value of x will be negative x. So I'm going to replace that with negative x. So negative x over x when x is less than 0. It's equal to 0 when x is equal to 0. And then for x is greater than 0, absolute value of x will just be x. So I can replace that with x. So x over x when x is greater than 0. Well, that's going to be equal to negative 1 when x is less than 0, 0 when x is equal to 0, and 1 when x is greater than 0. So now I have a better idea of what this function looks like. This function looks like, if I were to graph it, to the left of 0, it's just going to be negative 1. And then it's going to be 0 here, and then at 1, it's going to be, for x greater than 0, it's going to be positive 1. Okay, and you're just trying to evaluate the limit as x approaches 0 there. There are your options. Consider the graph and how it looked like how I just had it. You can probably just look at it, evaluate it just by looking at the function I just showed as well. So hopefully that gives you a good idea. All right, the function f is defined for all x in the interval from 3 to 6. And which of the following statements, if true, implies that the limit as x approaches 5 of f of x is equal to 12? A lot of these expressions, as I'm looking at a, b, c, d, especially c and d, it looks like it's trying to get us to think in terms of the squeeze theorem. So we have g, f, and h. Okay? There exists a function, I'm going to look at option A. There exists a function g with f of x is less than or equal to g of x for 3 to 6, and the limit as x approaches 5 of g of x is equal to 12. So we don't have 3 different functions, so we can't possibly squeeze one function between 2 functions in the cases of a and b. So I'm just going to rule those out right there. Okay, and then c and d should just follow from the squeeze theorem. So I can't really say too much. It should be pretty obvious which of these is right according to the squeeze theorem. So I would just say, look at the squeeze theorem. What does it say? And go from there, because this is just pretty much applying the definition of the squeeze theorem. Question 5. The function g is given by g of x is equal to 1 over x squared minus 4x plus 5. The function h is given there. If f is a function that satisfies, okay, so we're looking at the squeeze theorem. What is the limit as x approaches 2 of f of x? So follow the squeeze theorem, apply the limit as x approaches 2 of g of x and of h of x, and see if you can get the same value. You might have to do some algebraic manipulation and go from there, but it really shouldn't be too bad. Just trying to get the squeeze theorem. If the limit as x approaches 2 of g of x is the same as the limit as x approaches 2 of h of x, then the limit as x approaches 2 of f of x has to be equivalent to those two values, to those two. And if not, then we really don't have enough information to solve this problem. So let f be a function x. The value of the limit as x approaches a of f of x can be found using the squeeze theorem with the functions g and h. Which of the following could be the graphs of f, g, and h? So this is just pure visual representation of the squeeze theorem. And so really the only options are b and d, since a and c have are clearly not giving that visual representation, where f of x will be in between and squeezed so much that, except for at one point where they're pretty much equivalent. So you just have to look at b and d, and from that point you have to take a look at the ordering of those functions from there. Okay? All right, and I think that covers everything for this progress check.